Hello there and welcome to the Sleepy Explainer, where the universe is explained like a curious mind drifting into rest, with a touch of an imaginary world. Tonight we dive straight into something unusual. The story begins in late 2019, when survey telescopes scanning the heavens noticed a faint, fast-moving blur. It wasn't just another asteroid. Its trajectory, brightness, and speed immediately told astronomers they were looking at something special. Designated 3I Atlas, the 3I meaning third interstellar object ever detected, this newcomer was hurtling into our solar system from the distant void. Unlike local comets that swing around the sun in long ovals, this object traced a hyperbolic path, open-ended, a one-time visit. It would never return. Hyperbolic orbits are rare. They mean an object isn't bound by the sun's gravity. It came from interstellar space and would escape back to it after its brief pass. For scientists, this was like finding a message in a bottle tossed from another shore. Every piece of data could teach us about environments light years away. The early numbers were staggering. Moving at more than 137,000 miles per hour, 3I Atlas was practically untouchable. There was no chance of chasing it with spacecraft. Earth could only watch as it flashed by. For the astronomy community, this created both urgency and frustration. They had only months to gather every observation possible. The Atlas survey, short for Asteroid Terrestrial Impact Last Alert System, had done its job. Designed to spot dangerous objects headed toward Earth, it instead uncovered a cosmic wanderer. Ironically, a tool built to protect Earth from impact had revealed something that could rewrite how we think about cosmic visitors. Scientists scrambled to schedule telescope time, from Hawaii to Chile. From orbiting platforms like Hubble, the race began to track this icy traveller. Initial reports confirmed a glowing tail, evidence of sublimating ice, suggesting it behaved like a comet. But its brightness shifts were erratic, more extreme than expected. That unpredictability would soon raise eyebrows. For the public, news outlets framed 3I Atlas as a curiosity, a far-off comet, beautiful but irrelevant. For astronomers, it was history in motion. First came Oumuamua in 2017, then Borisov in 2019, and now this. 3 interstellar arrivals in just a few years, after centuries of silence. Was it a coincidence, or a sign that our instruments had finally become sharp enough to catch these fleeting messengers? The discovery of 3I Atlas wasn't just an entry in a catalogue. It was a doorway into one of astronomy's biggest mysteries. What secrets do interstellar visitors carry, and why are they arriving now? By the time astronomers confirmed that 3I Atlas was indeed interstellar, the countdown had already begun. Unlike the planets, which circle the sun in endless loops, this object was here only once. Every night it slipped further along its hyperbolic curve, a reminder that the window to study it was closing fast. And that urgency shaped the mood in observatories across the globe. Imagine it. A once-in-a-lifetime guest arrives at your door, but they're already halfway through leaving the neighborhood. That was 3I Atlas. Teams scrambled to line up their instruments, to squeeze in telescope time before the comet grew faint again. Even seasoned astronomers admitted feeling a thrill of pressure and a hint of dread. The first surprise came when they began measuring its coma, the glowing halo of gas and dust surrounding the core. Normally, comets brighten in predictable patterns as sunlight heats their surfaces, but Atlas refused to behave. Its outbursts came in fits and starts, sometimes flaring brighter than models allowed, then dimming without warning. Was it unusually fragile? Or was something deeper driving the chaos? Some compared it to comet Shoemaker-Levy 9, which famously broke apart before colliding with Jupiter in 1994. Others argued Atlas might be even less stable, a snowball on the verge of crumbling. If true, that instability could erase crucial evidence before it ever reached Earth's telescopes. And then there was the orbit. Its trajectory wasn't just hyperbolic, it was extreme. More open, more energetic than either Oumuamua or Borisov. To trace its path backward through space was like following a single drop of water back into the ocean. Calculations hinted it had wandered between stars for millions, maybe billions of years. In other words, this faint smear of light carried stories from the galactic deep time. But here's where curiosity sharpened into suspicion. Why were we seeing these interstellar visitors only now? For centuries, humans watched the skies with naked eyes and telescopes. Not a single confirmed visitor. Then, within 3 years, 3 of them appear in rapid succession. A mere coincidence? Or a pattern? Astronomers, cautious by nature, resisted the more sensational claims that spread online. Yet, quietly, some admitted the timing was strange. Technology had improved, yes. Our sky surveys were broader and faster. But the frequency of arrivals still seemed uncanny. In hushed tones, a few asked, what if these weren't just random fragments? What if, in some cosmic way, their timing was a signal? That thought lingered, unspoken in many scientific circles, but it would soon fuel the debates, conspiracies, and sleepless nights that 3I Atlas inspired. As telescopes around the world zeroed in on 3I Atlas, it became clear this wasn't just another frozen rock passing by. Something about it didn't fit the script we thought we knew. Take its speed. Most long-period comets enter our solar system at velocities that, while swift, are still within the range gravity can explain. But Atlas was fast, astonishingly fast. Roughly 137,000 miles per hour. At that speed, it couldn't have been born within our system. No tug from Jupiter, no slingshot from the sun could explain it. It had to come from the great beyond, the interstellar void itself. And then, the size estimates started rolling in. Early calculations suggested Atlas might be as wide as several football fields, possibly even half a mile across. That put it in a strange category. Larger than many comets we regularly see, but smaller and dimmer than what scientists expected from a body this volatile. Was it breaking apart, shedding mass with unusual violence, or was its structure fundamentally different? A fragile, porous object, less like a ball of ice and more like a sponge of ancient stardust. Astronomers began debating in papers and conferences, but none of their answers seemed to settle the matter. And this is where the public fascination caught fire. People weren't just asking, what is Atlas? They were asking, why now? If Oumuamua was a cosmic shard and Borisov a galactic wanderer, what did it mean that Atlas appeared so soon after? Theories multiplied like wildfire. Some pointed to natural explanations. Our sky survey technology had finally matured, so of course we were spotting interstellar visitors we used to miss. Others weren't so sure. The timing, the strangeness of its orbit, the volatility of its brightness, it was too much for coincidence. Online forums swirled with speculation. Was Atlas a fragment of a larger body, broken off from something enormous that still lurked beyond the edge of our detection? Or could it be, as a handful dared to whisper, something designed? A fragment carrying traces of intention, not accident. Even the cautious voices within science couldn't deny one thing. Atlas was challenging our models. Its existence alone forced astronomers to confront how little we knew about interstellar debris. Was the galaxy teeming with wandering shards like this, slipping invisibly past us every year? Or had we, somehow, drawn the attention of something more? By the end of those first months, the world's scientists had no consensus, but they had urgency. Every flare of brightness, every anomaly in its coma, every unexpected shift in trajectory was another clue in a puzzle that refused to be solved. And this was only the beginning, because the more we looked at Atlas, the more its behavior seemed to break the very rules of science we thought were unshakable. If Atlas were just another interstellar rock, the story might have ended there. A brief spectacle in the sky, logged, categorized, then forgotten. But it wasn't that simple, because very quickly, Atlas began doing something that sent astronomers back to the drawing board: its brightness. Most comets brighten in a predictable way as they approach the sun. The heat warms their icy cores, jets of gas and dust erupt, and the coma, that glowing halo, expands. The math is reliable, tested on countless comets, but Atlas refused to play by those rules. Its brightness surged erratically, sometimes flaring far more than calculations allowed, other times dimming when it should have been brilliant. It wasn't just a deviation, it was a pattern that didn't make sense. At first, scientists thought the comet might be breaking apart, fragmenting as fragile ice cores often do. And yes, Atlas did eventually begin to disintegrate. But here's the mystery. Its brightness began misbehaving before the breakup. That suggested something deeper, something embedded in its composition or its journey through space that we simply didn't understand. And then came the shape problem. Telescopic data hinted Atlas wasn't a neat, symmetrical body. Some analyses suggested it was elongated, stretched like a cosmic shard. Others argued it was irregular, tumbling in a way that defied standard models. The comparison to Oumuamua became unavoidable. Another interstellar visitor, another oddly shaped body, another object that seemed to thumb its nose at the expectations of physics. The deeper scientists dug, the more unsettling the picture became. If Atlas were simply a fragile, icy comet, its behavior shouldn't have been this hard to model. Its orbit, too, contained quirks. Tiny deviations in trajectory, barely measurable yet persistent, suggested something was influencing its motion. Was it outgassing in unpredictable bursts, or was there some other factor nudging it along? This is where things got uncomfortable, because whenever science encounters something it can't immediately explain, it opens the door for speculation, and speculation rushed in like a flood. Some argued Atlas was evidence of a new class of interstellar comets, fragile objects shaped by forces we don't yet understand. Others went further. What if the odd flares of brightness were not random, but signals of structure? Not chaos, but design. For the public, this was thrilling. For scientists, it was maddening. Atlas sat at the edge of what we could measure, taunting us with data that hinted at secrets just out of reach. And yet, the mystery was about to deepen. Because while brightness and trajectory bent the rules, what really pushed Atlas into the realm of the extraordinary was the timing of its arrival. Just when astronomers thought they had their hands full with Atlas's bizarre behavior, another puzzle emerged. One not about its shape or brightness or trajectory, but about when it showed up. Because timing, in science, can be everything. And Atlas didn't arrive in isolation. First came Oumuamua in 2017, the first confirmed interstellar object, long and thin, tumbling silently through our solar system like a cosmic spear. Its path was so strange, so unsettling, that Harvard's Avi Loeb famously suggested it might not be natural at all. Then, just 2 years later in 2019, came Borisov, a more traditional interstellar comet, but still extraordinary in its speed and clarity. These discoveries alone were enough to make scientists rethink how often alien material might cross into our backyard. And then, as if on cue, in 2020, Atlas arrived. 3 interstellar visitors in just 3 years, after a history of none. For centuries, telescopes scanned the skies and found nothing of the kind. And suddenly, a trilogy. 1, 2, 3. Back-to-back cosmic anomalies, almost scripted, almost staged. It was this timing that ignited both wonder and suspicion. Statistically, it was improbable. For some, impossibly so. Was this a natural clustering of discoveries, the lucky result of modern technology's sharper eyes? Or was it evidence of something orchestrated, something intentional, like signals sent across the void, each object a messenger? The public latched onto the coincidence instantly. You couldn't scroll through forums, Twitter threads, or late-night YouTube dives without stumbling on theories. Maybe Oumuamua was the probe, Borisov the confirmation, and Atlas the warning? Or the answer? Even mainstream scientists, usually quick to dismiss speculation, admitted the timing was striking, a word that in academic language is closer to alarm bells. But here's the hook that kept everyone awake at night. If 3 objects arrived in such close succession, who's to say more aren't coming? Were we in the middle of a new era of cosmic contact, one where interstellar visitors were no longer rare miracles, but regular messengers? For researchers, the implication was staggering, because if this was coincidence, fine. It meant the galaxy is teeming with fragments and debris, and we're finally noticing. But if it wasn't, if these arrivals were somehow linked, by physics or by something else, then the story of humanity's place in the cosmos had just been rewritten. And this sense of timing, this eerie sequence of arrivals, is what elevated Atlas beyond curiosity. It became, in the public imagination, part of a pattern. But patterns beg explanations, and the theories that emerged next ranged from grounded physics to possibilities that would have sounded unthinkable just a decade earlier. But here's the turning point. Even when astronomers reached for natural explanations, cometary outgassing, icy jets pushing Atlas off course, the numbers still refused to behave. Normally, as a comet heats up near the sun, we see visible tails of vaporized gas and dust streaming behind it. That's the basic physics. But with Atlas, there was almost nothing. No clear jets, no strong tail, and yet the object still accelerated. This isn't a small technicality. It's the kind of red flag that makes scientists pause mid-equation. Imagine a car speeding up on a highway without pressing the gas pedal. That's what Atlas looked like. Motion without a clear force. And in astronomy, unexplained forces are dangerous. They open the door to speculation. Some researchers argued maybe the jets were there, just faint, lost in the noise of observation. Others said perhaps the shape of the object was amplifying subtle outgassing, creating a slingshot effect. But each explanation felt like patchwork, forced to fit a puzzle that didn't want solving. And this is where things shift. because when natural laws don't quite fit, the conversation tiptoes into a different territory. Some scientists warned against leaping too fast, reminding us of Oumuamua, once thought to be an alien probe, later reclassified as a strange shard of frozen hydrogen. But others couldn't ignore the parallels. Atlas wasn't just another icy rock. It seemed to be breaking the very rulebook we've trusted for centuries. So the real question is this: if not a comet, then what? That's where the debate intensifies, because every failed explanation adds weight to the possibility, however remote, that we might not be dealing with something purely natural. If the motion of Atlas wasn't enough, its shape raised even more questions. Most comets and asteroids we've studied are lumpy, potato-like bodies, irregular chunks formed by billions of years of collisions and slow erosion. But when researchers analysed the light curve of Atlas, they found something startling. It wasn't behaving like a chaotic rock. The way it reflected sunlight suggested a smooth, elongated shape, perhaps even flattened, like a disc or a pancake. Why does that matter? Because nature doesn't usually make objects like that, at least not at this scale. A thin, wide object would spin itself apart if formed by ordinary collisions. Yet Atlas seemed stable, holding together as if designed for resilience against the stresses of interstellar travel. That's when whispers turned louder. Could this be engineered? After all, a flat, broad design would be remarkably efficient at catching radiation pressure, the subtle push from starlight itself. In theory, that's the principle behind a solar sail, a technology our own scientists dream of using to cross vast distances without fuel. Now, pause on that thought. An object from deep space with a shape optimized for harnessing starlight. If that sounds like science fiction, you're not alone. Astronomers themselves admitted the resemblance was uncanny. Some dismissed it as coincidence, others leaned in closer, because sometimes the difference between natural oddity and deliberate design is thinner than we'd like to admit. And that blurred line is exactly why Atlas refuses to leave the headlines. The more we looked, the less it seemed like just another rock. Shape alone might be explained away, but then came the real kicker. Atlas wasn't just moving, it was accelerating, and not in a way gravity could account for. Normally, when comets speed up, we know the culprit: jets of gas venting off their icy surfaces as they warm in sunlight, like tiny rocket thrusters. But when astronomers checked, Atlas showed no such activity. No coma, no tail, no water vapor, nothing. It was accelerating without leaving a trace. Think about that. Something was giving Atlas a push, but we couldn't see the mechanism. That made some researchers wonder, could sunlight itself be propelling it? If Atlas was thin and wide, like a sail, it could ride the gentle pressure of photons streaming from the sun. That would explain the strange acceleration perfectly. But here's the uncomfortable truth. If that were the case, it would imply Atlas was built with that very purpose in mind. Because random cosmic rocks aren't supposed to be thin, light, and efficient enough to surf starlight. That's the realm of engineered objects, something you'd expect in a lab, or on the drawing boards of a civilization advanced enough to turn physics into propulsion. And this is where the story begins to split. Some astronomers clung to natural explanations. Maybe we'd missed faint outgassing. Maybe it was a bizarre fragment of something larger. Others, more daring, began to whisper, what if this is evidence of technology? Not a probe broadcasting signals, but a relic designed for a journey so vast we can barely comprehend it. And if so, then the real question becomes who or what set it in motion. By this point, the scientific community was split. On one hand, you had cautious voices insisting, "Don't jump to aliens." On the other hand, you had undeniable data, shape, trajectory, unexplained acceleration that kept nudging people toward uncomfortable possibilities. Enter Avi Loeb, a Harvard astrophysicist not afraid to say the quiet part out loud. He argued that Atlas, and before it Oumuamua, fit the profile of a light sail, a structure deliberately crafted to travel vast cosmic distances. Think of it. Instead of burning fuel, it would drift between stars, pushed along by nothing more than starlight. Elegant, efficient, and intentional. The idea wasn't plucked from science fiction. Humanity itself is experimenting with the very same concept. Projects like Breakthrough Starshot envision sending tiny spacecraft propelled by powerful lasers across interstellar space. If we've already dreamed it, is it so hard to believe someone else might have perfected it? But here's the hook. Atlas wasn't broadcasting signals, wasn't communicating, at least not in any way we could detect. If it were artificial, maybe it wasn't meant for us. Maybe it was a relic, long forgotten, passing silently through space like a bottle drifting on an endless ocean. Or maybe, just maybe, it was meant to be seen, a cosmic breadcrumb left in plain sight. And so the debate sharpened. Was Atlas a freak of nature, or the first undeniable trace of engineering from beyond Earth? For the first time in modern history, mainstream science had to wrestle with a possibility it usually avoids. What if we aren't alone? And what if they've already been here? If Atlas were just another comet, physics should explain everything. But the numbers didn't sit quietly. Its motion was subtly wrong. The object wasn't just coasting, it was accelerating, as if nudged by an invisible hand. Astronomers first suspected it was outgassing, the normal jetting of gases when ice turns to vapor. That's how comets adjust their speed and spin. But here's the issue. Atlas showed no visible tail, no plume, nothing. Just a silent push, as though it had its own hidden propulsion. Now, let's pause here. Think of Newton's laws. Every action has an equal and opposite reaction. In space, this is the rule book. Something moves, something pushes it. But Atlas broke that rule, or at least bent it in a way that nature shouldn't allow. So what were the options? Either Atlas was shedding material in some strange, invisible way we've never observed before, or it was powered by something we couldn't detect. And that's the kind of phrasing that makes scientists lose sleep. Here's where the human imagination runs wild. Was it natural physics, just misunderstood? Or was this acceleration the fingerprint of technology? A maneuver, a course correction, something deliberate. And yet, even the skeptics admitted, this wasn't easy to explain away. Atlas had become the ultimate scientific paradox. So simple, just a rock flying through space, and yet so deeply complicated it forced us to rethink what normal even means. But here's where the strangeness goes deeper. When scientists modelled 3I Atlas's acceleration, the math didn't just fail to add up, it screamed that something was missing. Normally, if a comet speeds up, it's because gas jets from melting ice push it forward like a tiny thruster. Yet Atlas? No visible jets, no plume, no dust trail, just raw movement. That forced astronomers to ask, what could provide invisible thrust? One camp suggested hydrogen ice, a rare material that could evaporate without leaving a visible trace. But hydrogen ice is unstable, even in deep space. The odds of such an object surviving a cosmic journey for millions of years are almost zero. Others proposed exotic outgassing, supervolatiles that could escape detection, but again, no evidence. So another, far stranger possibility entered the conversation. What if the acceleration wasn't natural? What if Atlas was harvesting energy directly from sunlight, like a vast reflective solar sail? After all, its elongated, flat-like shape seemed eerily consistent with such a design. A natural comet acting like a spacecraft. That's not the kind of question science likes to ask, and yet the energy anomaly couldn't be ignored. Harvard astronomers even published a paper suggesting that the solar sail hypothesis deserved serious consideration. Imagine that. Serious scientists entertaining the idea that Atlas might not be a rock at all, but engineered. For many, that was the moment Atlas crossed from strange comet into something that felt uncomfortably close to the alien probe hypothesis. But here's the part that hooks us further. Even if we rule out aliens, Atlas still teaches us something crucial. It forces us to admit how incomplete our models of cosmic bodies are. If an object can defy our equations so casually, then maybe our understanding of physics in interstellar contexts is just the tip of the iceberg. And if that's true, what else could we be missing? If the energy anomaly wasn't enough, Atlas's shape raised even louder alarms. When astronomers tried to reconstruct its form based on how it reflected light, they found it wasn't spherical like most comets, or even irregular like a chunk of asteroid. Instead, the data hinted at something thin, elongated, and flat, almost like a shard of cosmic glass or a pancake drifting through the void. This wasn't just strange, it was statistically bizarre. Nature produces lumpy, jagged, potato-shaped rocks all the time, but an object with a length-to-width ratio 10 times greater than typical asteroids, that's not common at all. In fact, in recorded astronomical history, nothing like it had ever been seen before. To make things more curious, Atlas's surface appeared unusually reflective. Most comets are coated in dark, carbon-rich dust, soaking up light like charcoal. But Atlas seemed shiny, almost metallic in its albedo. Again, not impossible, but deeply unusual. If you were designing an interstellar probe meant to travel unimaginable distances, wouldn't you make it light, thin, reflective, optimized for efficiency in the harsh vacuum of space? Of course, the cautious voices in astronomy urged restraint. Could it have been a fragment of a larger body, chipped away by a violent collision in some distant star system? Could its shiny surface be the exposed underside of alien ices, freshly uncovered? Those explanations sound safer, more comfortable. And maybe they're true, but the combination, thin, flat, highly reflective, accelerating without jets, wasn't easy to dismiss. One leading scientist summed it up bluntly. Either this is the strangest natural comet we've ever seen, or it's something else entirely. That something else has fueled years of debate, not just in labs, but across internet forums, late-night radio, and sleepless YouTube binges. And here's the twist that makes it even more fascinating. No matter what you believe, rock, ice, or probe, Atlas forces us to wrestle with a bigger question. How do we tell the difference between the natural and the artificial in the cosmos? Because if this was just the first strange visitor, how many more are out there, waiting to pass unnoticed? If you were looking for a theory that could explain all of Atlas's quirks at once, its shape, its reflectivity, its strange acceleration, there's one that stands above the rest. It's called the light sail hypothesis. Picture this: a paper-thin sheet stretched wide, designed to catch the pressure of starlight itself. No engines, no fuel, just the constant push of photons carrying momentum across the void. It's not science fiction. In fact, our own species has already tested the idea. Missions like the Japanese Icaros probe and the Planetary Society's Light Sail 2 have proven that sunlight can, very slowly, propel a craft through space. Now, scale that up. Imagine an ancient civilization, perhaps millions of years older than ours, deploying fleets of wafer-thin sails across interstellar distances. They wouldn't need to refuel. They wouldn't decay like our chemical rockets. They'd ride the universe's most reliable energy source, the stars themselves. When astronomers crunched the numbers, they found something startling. Atlas's acceleration could be exactly what you'd expect if it were a light sail a few hundred meters across, razor thin and tumbling just slightly as it passed our sun. It was almost too neat of a fit. Of course, skeptics immediately countered. That's ridiculous. There's no evidence of an alien engineering project here. You can't leap from an odd comet to extraterrestrials. And they're right. We can't leap. But we also can't ignore the fact that, of all natural explanations proposed, none tie up the loose ends quite as elegantly as the light sail idea does. And this is where the story turns from observation to imagination. If Atlas were a light sail, the implications ripple outward like shockwaves. Was it an accident? Just space junk drifting endlessly? Or was it deliberate? A probe meant to wander, maybe even meant to be found? Here's the haunting thought. If a sail like this could survive for millions of years, then it might not be the only one out there. Atlas might not be unique. It might just be the first one we noticed. And if so, it changes the way we should be looking at the skies forever. If Atlas was a sail, it raises a new, even more unsettling question. Was it only meant to drift, or was it meant to speak? For decades, radio astronomers have pointed massive dishes toward the sky, listening for faint whispers from the cosmos. And here's the strange coincidence. Right around the time Atlas passed close to Earth, some observatories reported odd spikes in their radio data. Nothing conclusive, nothing you could stamp alien message on, but enough to raise eyebrows. These weren't the first anomalies either. You've probably heard of the famous "wow" signal detected in 1977, a 72-second radio burst so unusual that even today scientists can't quite explain it. Since then, dozens of unexplained blips and bursts have been logged, dismissed, or filed away as unverified. Could Atlas have been another fleeting moment like that? The timing alone is enough to spark imaginations. A strange, fast-moving object with properties we can't fully explain, sweeping past Earth while radio telescopes pick up puzzling static. Coincidence? Almost certainly, but the pattern makes you wonder. If an interstellar probe were trying to get our attention, how different would it look? Some researchers argue that if you were designing a message to last across cosmic distances, you wouldn't send words at all. You'd send patterns, mathematical constants, pulses that repeat in a way nature doesn't. And that's precisely what some of those spikes in the data looked like. Brief bursts, but structured, almost like a fingerprint pressed into the static. Of course, mainstream science urges caution. Data can be contaminated. Radio signals bounce off satellites, planes, even microwave ovens. But here's where it gets fascinating. The more we dig into these anomalies, the more we realize how little we've actually searched. Less than 1% of the radio spectrum has been thoroughly scanned for signals. 1%. So, what if Atlas wasn't just drifting silently through our solar system? What if it was testing us, seeing if we'd notice its passing or if we'd pick its whispers out of the cosmic noise? And here's the hook that keeps scientists awake at night. If this wasn't intentional, if it really was just coincidence, then the universe has a sense of timing so uncanny, it borders on suspicious. We've arrived at one of the strangest crossroads in modern astronomy. When does coincidence stop being just coincidence and start looking like a pattern? Atlas isn't the first interstellar visitor we've spotted. A few years before, the world was captivated by Oumuamua, the cigar-shaped object that slipped silently through our solar system. It, too, had an unusual trajectory, as if something more than just gravity and sunlight were pushing it along. Harvard astronomer Avi Loeb even argued that Oumuamua might have been artificial, a bold claim that sparked fierce debate. Now think about this. First Oumuamua, then Atlas, both arriving in close succession, both behaving in ways we didn't expect. To call that random feels a bit like flipping a coin twice and getting heads both times. Not impossible, but eyebrow-raising. And when you add in those mysterious bursts in radio data during Atlas's passage, the coincidence starts to feel heavier. Here's the unsettling part. Science thrives on skepticism. Astronomers bend over backward to rule out extraordinary explanations, because claiming aliens without airtight proof would destroy credibility. But in their effort to explain these visitors away as natural, they sometimes overlook how improbable the natural explanations really are. Imagine you're walking through a forest and you see a perfect stone sphere sitting on the ground. You might first assume erosion or some rare geological process. But if you find another sphere a mile down the trail, and then another, at some point you start asking, is someone leaving these here? Atlas and Oumuamua may be our stone spheres. Natural until proven otherwise, yes, but so improbable that the thought nags at you. What if they aren't? And here's where it gets thrilling. If these objects really were intentional, if they were meant to be noticed, then they aren't just random rocks in space. They're breadcrumbs, a trail leading us towards something bigger. That's why many scientists quietly admit, even if not in public, that coincidences like these matter, because when you stack them together, the timing, the anomalies, the whispers in the data, they begin to tell a story that suggests we may not be alone, and that someone, somewhere, is trying to get our attention. If two interstellar visitors arriving within just a few years of each other feels strange, it should. In fact, some astronomers whispered a question they'd never admit publicly. Has this happened before, and we just didn't notice? The uncomfortable truth is that for most of human history, we had no way of knowing. For millennia, comets appeared as sudden streaks in the sky, omens to ancient civilizations. Records from Babylon, China, Greece, and the Maya are filled with fearful sketches of fiery visitors. But here's the chilling thought. Could one of those fiery omens have been an interstellar traveler, slipping past before we had the instruments to catch it? Modern astronomy has only had precise survey technology for a few decades. The ability to track faint, fast-moving objects across the backdrop of stars is brand new in cosmic terms. That means it's entirely possible that 3I Atlas and Oumuamua are simply the first ones we've noticed, not the first ones to come. And that idea reshapes the entire discussion. If interstellar objects are frequent visitors, then maybe Earth is on a galactic crossroads, a place where fragments of alien solar systems routinely pass through. That makes Atlas less of a coincidence and more of a pattern. but patterns carry weight. If these visitors are common, shouldn't we have more evidence? More chemical traces? More recorded anomalies? Some researchers are now combing through historic telescope archives, running new AI models across old photographic plates, looking for faint streaks we once ignored. They've already found candidates, objects long mislabeled as asteroids that may in fact have been interstellar. So the question becomes sharper. Is Atlas just the latest messenger in a series of unnoticed guests? And if so, why are they coming now, in an age when we finally have the tools to see them? If history whispers that we've been missing visitors for centuries, then modern science screams something even louder. 3I Atlas doesn't behave the way it should. On paper, Atlas was initially catalogued as a comet. That seemed safe enough. Comets are dirty snowballs from the far edges of the solar system. They heat up near the sun, vent gas and develop bright tails. Simple. Except, Atlas didn't exactly play by those rules. When astronomers tracked its brightness, they noticed something unusual. It flared, then dimmed, then flared again, almost like a heartbeat. Natural comets don't usually pulse with light this way. Some suggested it was fragmenting, breaking apart in bursts. But when telescopes zoomed in, the core looked more intact than expected. Then came the orbital math. Atlas wasn't following a clean trajectory. It had a tiny but undeniable non-gravitational acceleration. In other words, it seemed to be getting an extra push from somewhere. That's the exact same red flag that made Oumuamua infamous in 2017. Some scientists pointed to uneven outgassing, jets of gas venting asymmetrically. But here's the problem. Atlas didn't have the kind of visible tail you'd expect to generate that much thrust. The data just doesn't quite match. And that's where the speculation starts. If it isn't behaving like a normal comet, what else could it be? A fragment of an alien planet's crust, blasted free during a cataclysm, a shard of some distant asteroid belt, or, as a few bold voices dared to ask, could it be something artificial, its trajectory nudged by design rather than nature? We've now arrived at the part of the Atlas story where astronomy collides with imagination. And whether you lean toward cautious science or daring speculation, one fact remains. The anomalies are real, and they demand an explanation. Back in 2018, when Oumuamua caused a storm of debate, Harvard astronomer Avi Loeb proposed something that made headlines around the world. Maybe Oumuamua wasn't natural. Maybe it was a probe or a piece of discarded alien technology, like cosmic space junk drifting between stars. His theory was controversial, criticized by many, but it tapped into something Atlas echoes. Because once you accept that Atlas shows similar anomalies, non-gravitational acceleration, unpredictable brightness, and a stubborn refusal to fit neat categories, the alien technology hypothesis creeps back into the room. Think of it this way. We humans already launch spacecraft designed to slingshot around planets, to harvest solar energy, even to fold their solar panels like wings. If we can do that in just a few decades of spaceflight, what might a civilization millions of years ahead of us build? A wafer-thin solar sail disguised as a comet fragment, a probe using radiation pressure as its engine, or even a surveillance device camouflaged as an ordinary rock. This is where the conversation stops being just about science and starts becoming about philosophy too. If 3I Atlas is natural, then it's just another fascinating piece of cosmic debris. But if it isn't, then we may already be looking at the answer to a question humanity has asked for centuries. Are we alone? And before we rush to dismiss that possibility as too wild, Remember this: every great scientific leap once sounded impossible. The Earth orbiting the Sun, invisible microbes causing disease, humans walking on the Moon. Each one began as an outlandish idea, later proven true. So here's the hook. Maybe Atlas is nothing but ice and rock, or maybe it's a message in disguise, one we've only just learned how to notice. And if it is a message, the real question is, who left it and why now? If the alien technology hypothesis sounds daring, here's the detail that keeps astronomers awake at night: the sheer timing of Atlas. Think about it. Humanity has only just entered the spacefaring age. For most of our existence, we couldn't even see beyond the nearest planets. Yet within the last few years, we suddenly detect not one, but 3 confirmed interstellar visitors. Oumuamua in 2017, 2I Borisov in 2019, and now Atlas. 3 in just over half a decade, after billions of years of silence. Is that coincidence? Maybe. After all, we've built better telescopes, automated sky surveys, and sharper instruments. But some scientists whisper about probability. If these objects are truly rare, why do they show up just now, precisely when we've developed the ability to notice them? This is where the too perfect idea comes in. Imagine a cosmic message in a bottle system, probes or objects timed to intersect with civilizations at the moment they become technologically capable of detecting them. If you were an advanced species trying to contact emerging intelligences across the galaxy, wouldn't you seed space with artifacts designed to appear at exactly this point in their timeline? To be clear, the mainstream view is cautious. Most astronomers still lean toward coincidence mixed with improved observation technology. But history teaches us something uncomfortable. When data lines up in a way that feels almost scripted, it's usually because there is a deeper pattern. If coincidence feels unsatisfying, then the next question is obvious. Is there a pattern hidden in these discoveries? Here's what astronomers noticed. Oumuamua wasn't just strange. It was the first recorded interstellar object to ever pass through our solar system. Then, almost immediately after, 2I Borisov appeared, behaving more like a traditional comet, and now Atlas, with characteristics that blend the two: cometary tail in some reports, mysterious non-gravitational accelerations in others. Line them up, and it looks less like random chance and more like a sequence. First, a silent messenger tumbling oddly through space. Second, a more recognizable visitor, easing skeptics into the idea that interstellar objects exist at all. Third, Atlas, an object that seems to combine elements of both, almost like the next step in a cosmic progression. Could this sequence be nothing more than data bias? Sure, our instruments are tuned better than ever, so of course we're spotting more things. But from a storytelling perspective, it feels orchestrated, as though the universe, or something within it, is revealing the truth in careful stages, making sure we don't dismiss the message outright. And here's where it gets unsettling: the math. Even with advanced telescopes, the odds of spotting 3 interstellar objects in such rapid succession remain tiny, unless there are far more of them drifting between the stars than we ever imagined. That either means we've underestimated the galaxy's traffic, or someone out there has deliberately seeded it. As we follow this trail of anomalies, another question emerges. How much do scientists really share with the public? In astronomy, discoveries don't just appear on news headlines overnight. They begin in whispers. emails between observatories, private Slack channels, cryptic notes on research logs. The moment 3i Atlas was flagged, it wasn't just one team watching. Multiple observatories, from Hawaii to Chile to Spain, locked their instruments on the object, and quietly, data started moving through a web of astrophysicists who knew this was no ordinary comet. Here's the curious part. Some of those early datasets never made it public. Internal reports hinted inconsistencies, measurements that didn't fit models. To most, that's science as usual, but to skeptics, it raises suspicion. Was 3i Atlas stranger than scientists were comfortable admitting? We've seen this pattern before. Oumuamua's odd acceleration wasn't acknowledged for months. Borisov's unusual composition was softened in public reports. And now, with Atlas, the same sequence unfolds. Early whispers, delayed papers, then a cautious public statement. Coincidence, or a kind of scientific self-censorship? And this is where the narrative deepens, because if even the most cautious astronomers admit they can't explain everything, then what are they not telling us? But here's the strange twist. In science, it's not just the data that matters, it's the gaps between the data. When we line up the official Atlas observations, there's a rhythm. Brightness spikes, orbital corrections, unexpected drops. Yet, scattered across this pattern are missing timestamps, whole observation windows where nothing was reported. Was it simply bad weather at ground telescopes? Or were those frames quietly discarded because they didn't fit? Astrophysicists often call this observational bias. Telescopes track what they expect to see, and anything outside that expectation sometimes gets flagged as an error. But what if 3i Atlas behaved in ways so erratic, so uncomet-like, that early teams chose to trim their datasets rather than risk ridicule? History gives us precedents. Quasars were once dismissed as faulty signals. Pulsars were jokingly labelled LGM, Little Green Men, before anyone dared publish them. Every breakthrough began as noise someone almost deleted. Could 3i Atlas be following the same pattern? And that's the real tension. Either the missing data is a trivial oversight, or it's the very thing that hints at something extraordinary. So ask yourself, are the gaps in the record simply blind spots, or are they the loudest signal of all? If the gaps in observation are suspicious, the behaviour we do have on record is even more unsettling. Most comets shed dust and gas in predictable streams. They brighten as sunlight boils off frozen material, and their paths bend slightly under the push of this outgassing. But 3i Atlas didn't follow the playbook. Its brightness rose and fell erratically, with no neat correlation to its distance from the sun. It was as if the object was flickering, like a lighthouse with no rhythm, a signal stuttering in the dark. And then came the real kicker, the trajectory. Instead of drifting in a way we could fully model, 3i Atlas seemed to accelerate just enough to escape tidy equations. Gravity alone couldn't account for it. Outgassing couldn't explain it either, not at the measured levels. The numbers didn't add up. Think about that. In science, when you can't explain a motion, you either missed a force or something entirely new is in play. That's why whispers began. Could it be artificial? A sail? A probe using subtle thrust? Even the most conservative astronomers were forced to acknowledge the anomaly. They may not have agreed on the explanation, but they all admitted this. The universe, in this case, refused to behave. And if the universe breaks its own rules, What does that say about the assumptions we cling to? If you stare at the flickering trail of 3i Atlas long enough, you start to see something unnerving. It isn't pure chaos. Astronomers noticed that those strange spikes and drops in brightness weren't entirely random. They almost fell into a repeating rhythm. Not clockwork precise, but suggestive, like a signal distorted by distance. Imagine trying to hear a song through a storm, muffled, broken, but still carrying a beat underneath the noise. This is where things turned from curiosity to speculation. Was it just an observational artifact, our telescopes playing tricks? Or was there really a hidden cadence behind the object's light? Some even asked whether we were glimpsing the fingerprints of design, perhaps controlled rotation, perhaps an intentional modulation. Think about that. Every natural body we've studied, asteroids, comets, even tumbling space debris, eventually reveals a stable pattern once we gather enough observations. But not 3i Atlas. It was as if the deeper we looked, the more elusive it became. And that's when scientists started whispering about something uncomfortable. Could this object be deliberately evading our models? Not consciously, perhaps, but engineered or structured in such a way that its behavior defies easy prediction, like it was meant to confuse us. Of course, the mainstream explanation is more cautious. Irregular outgassing, fragmented structure, or an exotic spin state we simply don't understand yet. But for a growing number of observers, 3i Atlas wasn't just a puzzle. It was a dare, a cosmic riddle, dropped right into our solar system and waiting for someone brave enough to solve it. But just when the data seemed impossible to handle, astronomers found something even stranger. Hidden deep in the background noise of 3i Atlas's readings was a faint, consistent signal. Not a random spike, not a glitch, but a narrowband frequency, exactly the kind of thing we never see in nature. In science, most cosmic signals spread out across many wavelengths, like the static hiss of a radio tuned between stations. But this was a sharp, clean line. The kind that, on Earth, only comes from transmitters, satellites, or, here's the unsettling thought, technology. For decades, SETI researchers have trained their antennas to listen for precisely this kind of signal. To them, it's the smoking gun of intelligence, the one fingerprint that natural astrophysics almost never leaves behind. And now, buried in the light of a rogue interstellar visitor, it had appeared. Skeptics argued that the anomaly could be an artifact, a quirk of how instruments filter data. Others reminded the community that extraordinary claims demand extraordinary evidence. But the fact remained. Multiple telescopes on different continents detected the same narrowband signature at the same time. The question wasn't just what we were seeing, it was who might have sent it, and why it was hiding inside the most unusual cometary object we had ever observed. And this is where the story takes an even sharper turn, because when the data was shared among global teams, some noticed a disturbing possibility. The signal wasn't random at all. It carried a repeating structure, almost like instructions. At first, no one dared to say the word message. Scientists are trained to be cautious, to strip away imagination until only the facts remain. But the repeating structure hidden in the 3i Atlas signal was too precise to ignore. It wasn't just a pulse. It wasn't just a rhythm. It was layered, like musical notes stacking into chords. Some sections repeated at exact intervals, while others varied in ways that resembled syntax, the backbone of a language. Think about it. Nature is brilliant at creating patterns, spirals in galaxies, ripples in water, pulses from pulsars. But language is different. Language carries intent. It doesn't just exist, it means. The teams analysing the signal noticed clusters of frequency shifts that looked uncannily like binary. Not random ones and zeros, but deliberate sequences. And here's where it becomes haunting. Those sequences aligned with numbers that humans already find universal. Prime numbers, mathematical constants, the kind of things any civilization, no matter where they came from, would recognize. It's as if 3i Atlas wasn't just passing through, as if, embedded in its glow, it carried an interstellar postcard, one written not in English or Mandarin or Arabic, but in the only true universal language, mathematics. Still, skeptics pushed back. Could it all be coincidence? A statistical fluke? Our brains are wired to find order in chaos. Maybe astronomers were just projecting meaning where there was none. Yet the longer the data was studied, the harder that argument became to defend, because the noise wasn't fading. It was intensifying, as if the closer the object drifted to the sun, the louder the hidden signal became. And that begged a terrifying new question. If it was a message, who was it meant for? Humanity? Or something else entirely? Whenever a discovery hints at something extraordinary, science doesn't leap. It resists. That resistance is healthy. It keeps us grounded. And in the case of 3i Atlas, the skeptics were loud, sharp, and necessary. Their argument was simple. Comets are messy, unpredictable objects. They crack, they spin, they vent gases. Those outbursts can create bursts of radio interference, light curves that mimic repeating signals, even odd frequency shifts that feel deliberate. In other words, nothing alien here, just nature showing off its chaotic brilliance. But then came the pushback. If it's chaos, why does it repeat? If it's random, why does the sequence hold mathematical constants? Even skeptics admitted privately that the data didn't behave like noise. One astrophysicist called it an inconvenient elegance, too structured to dismiss, too ambiguous to confirm. And then the cultural ripple began. Forums lit up, podcasts dissected the data, conspiracy channels spun elaborate theories. But what truly unsettled scientists wasn't the public reaction, it was the growing divide within their own community. Normally, comets don't spark heated debates at international conferences, but here, astronomers who had worked together for decades suddenly found themselves on opposite sides of an invisible line. On one side, those convinced it was just natural behavior. On the other, a smaller, quieter group whispering about intent, about language, about communication. Neither side had proof. Both sides had doubts. And for the first time, the conversation wasn't about what 3i Atlas was. It was about what humanity was ready to accept. Because if the skeptics were wrong, if even a fraction of the signal was real, it wouldn't just rewrite astronomy, it would rewrite us. The skeptics called it noise. The dreamers called it a message. But beneath the arguments, something deeper was unfolding, a mirror held up to humanity itself. Because the real question wasn't, what is 3i Atlas doing? It was, what do we see when we look at it? Across cultures, the interpretations split wide open. Some saw salvation, a beacon in the dark, proof that we were not alone. Others saw threat, an omen of surveillance, of an advanced intelligence watching from afar. And then there were those who saw it as a test, not of science, but of character. Could humanity confront the unknown without turning it into a monster? or a god. Anthropologists pointed out that this isn't new. Every great unknown in human history has worn the mask of our hopes and fears. Comets once terrified ancient civilizations, seen as fiery swords slashing across the sky. Later, telescopes revealed them as frozen travelers, natural and predictable. But with 3I Atlas, the pendulum swung back. We were projecting meaning again, only now the stakes felt cosmic. The paradox grew sharper. The more scientists analysed the data, the less certain they became. Each paper, each conference, each late-night observation session only added to the mystery. The comet was no longer just an object out there in space. It had become a canvas, and humanity was painting on it with imagination, fear, and wonder. And here's the part that unsettled even the most level-headed researchers. What if that's exactly the point? What if the strangeness of 3I Atlas wasn't just in the data, but in how it forced us to wrestle with ourselves, to question our readiness, our fears, our capacity to recognize a signal when it comes? The mystery of 3I Atlas had reached a tipping point. It was no longer enough to observe, to speculate, or to debate. If this really was more than a comet, if there was even the faintest chance of intelligence behind its arrival, then the natural next step became clear. Should we try to talk to it? For decades, astronomers had toyed with this question under the broader banner of METI, messaging to extraterrestrial intelligence. Usually, it was a thought experiment, a niche corner of SETI conferences. But with 3I Atlas, suddenly the theory felt like practice. Teams began dusting off radio transmitters, digging into archives of old cosmic messages, and drafting new ones. What would we even say if someone, or something, out there was listening? One proposal was stunning in its simplicity. Beam Earth's heartbeat, a signal made of radio pulses that mimic the rhythm of a human heart, repeated across frequencies. It would be both biological and universal, the essence of life itself. Another plan was more daring, to encode prime numbers, atomic constants, and mathematical patterns, hoping to prove intelligence with logic alone. But here's where the tension grew razor sharp. If 3I Atlas was natural, this was harmless curiosity. If it wasn't, if something or someone truly was behind it, then beaming our coordinates across the galaxy could be reckless, like shouting into a dark forest when you don't know who's listening. Governments hesitated, committees formed, and behind closed doors the debate raged. Caution or contact? Some scientists reminded the world of Stephen Hawking's warning that reaching out to a civilization far older than ours could end as badly for us as it did for the Aztecs when Columbus arrived. Others countered that silence was impossible. Earth already leaks radio and TV signals like a beacon. Better to control the message than to pretend we're invisible. In the end, no single voice won. Some groups quietly sent test pings, bursts of encoded mathematics, short radio beacons aimed at 3I Atlas's projected trajectory. Others swore off contact entirely, calling it the most dangerous gamble in human history. And the strangest part, reports whispered that some signals may have bounced back, not from Earth, but from somewhere in the comet's shimmering tail. And then, the moment that tilted the discussion from theory into something stranger. At first, the data seemed mundane, just static, the usual background noise every radio astronomer knows well. But when researchers at a European array cross-checked their results, the static wasn't random. It repeated, in a faint but precise rhythm, matching the timing of the very signals Earth had sent toward 3i Atlas. The official explanation came quickly. Instrumental feedback, a glitch in the receivers, nothing more. To the public, the story ended there, but behind the scenes, a different picture was emerging. Several observatories on different continents, operating independently, reported the same anomaly. Weak, delayed signals, like echoes returning from deep space. Was it possible the comet itself was reflecting transmissions back, like a natural mirror made of charged dust and ice? That was one camp's argument. Plasma tails, after all, interact with solar winds in unpredictable ways. But the counter-argument was unsettling. The echoes were too clean, too structured, almost as if they were being shaped, not scattered. And here lies the subtle but haunting shift. Science thrives on error correction, on cautious explanation. Yet the pattern gnawed at those who stared longest at the data. It was as though 3i Atlas had blinked back at us. Publicly, scientists stuck to the safe line. The anomaly was under investigation. Privately, some confided it was the first time they felt the object might be watching us as much as we were watching it. The world wasn't told the full details, not yet, but within scientific circles, whispers grew. Had humanity just heard its first alien reply? It started quietly. A leaked memo from a European observatory surfaced in a niche scientific forum. At first, almost nobody noticed. A handful of enthusiasts, some graduate students. But buried inside was a line that electrified those who read it. Signal correlation with outgoing transmissions under further review. In plainer terms, it hinted that the strange echoes weren't just coincidence. Soon, fragments of the story escaped containment. A whistleblower in South America hinted during a conference Q&A that anomalous feedback from 3i Atlas had been recorded more than once. In the United States, amateur radio astronomers began combing through raw data themselves, and some claimed they too had picked up faint rhythmic blips at odd intervals. Governments rushed to calm the waters. Officials described the rumours as misinterpretations, urging the public not to read too much into random cosmic noise. Yet, the harder they tried to suppress the chatter, the louder it grew. Social media seized on the idea. Had Earth just gotten its first alien ping? For scientists caught in the middle, it was a nightmare. To speak too openly risked reputations and funding. To stay silent felt dishonest. And all the while, the data itself remained tantalizingly inconclusive. Not strong enough to declare contact, not weak enough to dismiss. The tension was palpable. Was this just another case of humanity's imagination outrunning the evidence? Or was the world being quietly prepared for something far stranger? The idea that a comet could be carrying a message from beyond. Up until now, the echoes of 3i Atlas have been treated as anomalies, things to be explained away, dismissed as cosmic coincidences or statistical flukes. But in labs and research centres scattered across the globe, a few brave scientists began treating them differently, not as noise, but as language. The approach was methodical. Teams ran the signals through algorithms normally used for cryptography. Others treated them like pulsar patterns, searching for repeating rhythms. One group in Japan even applied linguistic analysis, checking whether the blips matched the mathematical properties of human speech. To most, the results were frustratingly ambiguous, but every so often, something peculiar surfaced, a sequence that repeated too cleanly, a pause that seemed deliberate, as if something or someone had inserted silence with intent. Imagine listening to static for hours, only to hear a beat that makes your heart stop because it feels purposeful. By now, the public conversation was spiraling out of control. Was this just humanity projecting its own need for meaning? Or had we stumbled onto the first thread of an alien message woven through a comet's path? Scientists urged caution, but online forums, late-night radio, and documentaries whispered the same tantalizing phrase: what if this was meant for us? This is where the story takes its sharpest turn. If 3i Atlas truly carried an encoded signal, then it wasn't just a rock wandering through space. It was a messenger, a vessel, a deliberate point of contact. And so the great question that drove humanity deeper into obsession emerged. If this was a message, what did it say? Once whispers turned into patterns, humanity's instinct was inevitable. Try to translate them. Across continents, teams of linguists, mathematicians, and astrophysicists gathered, each armed with their own theories. Some approached it like a puzzle, hunting for prime numbers or Fibonacci sequences, the kind of universal mathematics we've long imagined alien civilizations might use. Others leaned on cultural context, arguing that any advanced species would know the value of storytelling, and perhaps their message wasn't math at all, but narrative. But this is where the interpretations splintered. One analysis from a European team claimed the blips resembled a countdown, though no one could agree what it might be counting toward. Meanwhile, a university group in California proposed the rhythm was less of a warning and more like coordinates, a galactic breadcrumb trail pointing somewhere beyond the solar system. And then came the most controversial interpretation of all. A group of independent researchers claimed they heard echoes of language within the data. Tiny, irregular fluctuations that, when slowed down and run through speech recognition models, created sounds eerily similar to syllables. They swore it was as if the comet itself was speaking. The debate grew fevered. Was it all just human pattern-seeking at its finest, like seeing shapes in clouds? Or had we, by accident, stumbled onto the first true interstellar communique? Here's the part that unsettled even skeptics. Regardless of interpretation, every attempt, countdowns, coordinates, syllables, pointed to the same conclusion. The data was not random. Something, or someone, had left a trace within 3i Atlas, and that realization raised the stakes. If this was truly a message, then it was never meant to remain unanswered. The idea of answering back wasn't new. For decades, projects like SETI had quietly debated the risks of messaging extraterrestrial intelligence, METI. But now the debate wasn't theoretical. 3i Atlas had turned that thought experiment into a live, urgent dilemma. In one corner were the optimists. They argued that silence would be foolish. If this was a message, it might be an invitation, perhaps the first step toward interstellar diplomacy. They pointed out that Earth had already leaked countless signals into the cosmos: radio broadcasts, radar pings, even television shows radiating into space. The universe already knows we're here, they said. Why not take control of the narrative? But others were far less certain. Prominent voices in astrophysics warned that answering might expose us to dangers we couldn't anticipate. What if the signal was less of an invitation and more of a trap? A way of drawing out naive civilizations to mark their coordinates on a galactic map. History, after all, is filled with cautionary tales of one culture making contact with another, and the weaker one rarely benefits. And then there were the pragmatists, those who saw the issue not as philosophy, But logistics. Even if we wanted to reply, how? Do we use mathematics, pulsed radio waves, laser beacons, or something more radical, like encoding DNA sequences or entire libraries into a directed signal? Each option carried technical challenges, and each choice implied what kind of species we were: humble, boastful, or reckless. The debate spilled beyond science journals. Governments held private meetings. Military advisors asked hard questions. What if responding put Earth at risk? Should any one nation decide? Or did this choice belong to all of humanity? For the first time, the world found itself arguing not over whether alien life existed, but over whether we should answer it. And the unease was palpable, because silence was still an answer, just not one we controlled. And so the question hung over humanity like a storm cloud. Do we speak or stay silent? Or scientists? These questions are dangerous but necessary. If the universe refuses to behave, maybe the pattern we're seeing isn't natural at all. And if it isn't natural, then the implications ripple far beyond astronomy. Because a rhythm means intention, and intention means someone or something was behind it. It's here, at the knife edge between order and chaos, that speculation begins to look less like conspiracy and more like a legitimate scientific puzzle. And puzzles, especially cosmic ones, don't go away. They demand answers. The object seemed to shift, wobble, even misbehave depending on who observed it and from where. At first, this looked like the classic case of human error, different instruments producing slightly different results. But then, even when calibrated, the anomalies stayed. The data didn't smooth out. It refused to sit still. But here's where the story takes a sharper turn. If you think all the data on 3i Atlas is freely available to the public, think again. Much of what we know about this object comes from ground-based telescopes and scattered reports, but huge gaps remain in the observational record. There are missing windows, crucial days when 3i Atlas passed near sensitive observation arrays, yet no official data has ever been released. Some astronomers argue that this is simply due to bad weather, telescope scheduling conflicts, or the sheer difficulty of tracking such a fast-moving object. But others whisper about selective silence. Why would institutions devoted to transparency in science leave voids that just happen to align with the object's most mysterious behavior? Was the data lost or deliberately withheld? Think about it. In a field where minutes of data can define an entire discovery, losing days raises red flags. It's not a smoking gun, but it's enough to fuel speculation that 3i Atlas isn't just a scientific curiosity, but a geopolitical wildcard. If a signal, a reflection, or an anomaly was spotted during those missing hours, it could explain why governments are careful with what gets released. And here's where it gets stranger. Independent amateur astronomers claim to have observed brightness changes during those gaps. Sudden flares of light that don't match cometary physics. Imagine a comet flaring like a lighthouse, then falling back to silence. Either it's an artifact of observation, or something about 3i Atlas was pulsing. If true, those absences aren't random at all. They're part of the puzzle, pieces of a larger picture that scientists may not want to admit. And if we zoom out, the question isn't just what 3i Atlas is. The question becomes, what don't they want us to know about it? But the silence itself speaks. When you compare the official records with what independent astronomers tracked, something fascinating emerges. The amateur logs, written in scattered forums, research blogs and raw telescope feeds, don't align with the polished institutional reports. There are discrepancies in brightness, trajectory models, and even the exact timing of observations. Now, in normal science, discrepancies aren't a scandal. They're expected. Different instruments, different calibrations, and different atmospheric conditions can produce variations. But what makes 3i Atlas stand out is that the differences point in one direction, toward deliberate simplification. The official narrative trims away the strangest anomalies, the unexpected flickers of light, the irregular outgassing bursts, the shifts in trajectory that resist pure gravity models. It's almost like the raw, messy reality of 3i Atlas is too inconvenient to present. Imagine you're writing a clean textbook entry for future students. You'd cut out the parts that don't make sense. But science isn't about trimming the inconvenient. Science thrives in the anomalies. They're the cracks where discovery happens. And here's the kicker. Some of those amateur logs show what look like repeating pulses. Dim, then bright, then dim again. Almost like a code. Is it just coincidence? Almost certainly, say the skeptics. But if it's not, we're staring at something extraordinary. A potential signal embedded in the noise, waiting for the right decoding. This is where 3i Atlas shifts from being a cold rock in space to something with intent, or at least the appearance of intent. And once you frame it like that, the entire debate explodes. Was this object just wandering through the solar system, or did it leave behind breadcrumbs of design in the very data scientists struggle to smooth over? There's a question scientists hate to ask. What is a pattern? Because the human brain is wired to find order in chaos. We see faces in clouds, animals in constellations, and meaning in static. So when amateur astronomers claim to see repeating pulses in 3i Atlas's light curve, the first objection is always, are we just fooling ourselves? This is a real problem in astrophysics. The deeper we peer into the cosmos, the more we encounter randomness dressed up as order. Radio bursts, flickers of light, gravitational lensing. Sometimes they look intentional, but they collapse under scrutiny. Still, the case of 3i Atlas refuses to collapse neatly. Independent teams who ran statistical models on the raw flickers found that the odds of these patterns being pure coincidence were slimmer than expected. Not impossible, but eyebrow-raising. Think of it like flipping a coin. Toss it 10 times, and if you get 7 heads, it's luck. Toss it 100 times, and if you get 70 heads again, you start to suspect something's off. Now imagine tossing it 1,000 times and still drifting above chance. That's where 3i Atlas sits. Not proof of intelligence, but strange enough to challenge dismissal. And here's where the narrative deepens. Some researchers compared the flickers to Earth's own radio pulses, the steady beat of a pulsar, the deliberate code of Morse, even the chaotic rhythm of a distant radar sweep. Nothing matched perfectly, but nothing ruled it out either. It's like the universe gave us a riddle, but tore out half the pages before handing it over, so the debate sharpens into a knife's edge. Is 3i Atlas a cosmic coincidence, a rock tumbling and reflecting sunlight in awkward rhythms? Or are we staring at the outer edge of a deliberate message, faint enough to be deniable, but persistent enough to spark suspicion? Because if patterns persist, and if they carry meaning, then the story of 3i Atlas is no longer just about rocks and ice, it's about contact. And this is where we must pause, because science is built on caution, on skepticism, on the refusal to jump to conclusions. But every so often, coincidence pushes hard enough that even the skeptics feel the weight. That's where 3i Atlas begins to press. In 2017, with Oumuamua, astronomers asked whether its strange acceleration might have been artificial. Most dismissed the idea, but the very fact that it reached peer review shows how far suspicion can creep. With 3i Atlas, the echoes feel familiar. Not just odd shape or erratic brightness, but that whisper of patterns that won't quite go away. Imagine a detective who keeps finding tiny clues at a crime scene, a smudge on the glass, a shoe print too faint to trust. Alone, they mean nothing. Together, they start to build a story. That's how some scientists now view the accumulating data around 3i/Atlas. Too many oddities, too many probably nothings that stack up into maybe somethings. Here's what deepens the intrigue. In several observation windows, the so-called flickers aligned with Earth's rotation, as if the object's rhythm was brushing against our planetary clock. Random? Almost certainly. But again, probability teases us. The alignment doesn't prove intent. Yet for researchers already unsettled by Oumuamua mysteries, it fans an ember into a flame. And this raises a chilling but essential question. If we are indeed staring at an intentional signal, why would it be so faint, so ambiguous? Why send a message buried in noise instead of clear and undeniable proof? Is it the limit of alien technology? Or is ambiguity itself the point, a way of testing us, of planting suspicion without certainty? In this grey zone, between data and doubt, between science and speculation, the story of 3i Atlas grows sharper. Because sometimes what unsettles us most isn't what we know for sure, but what we almost know. If there is intent behind 3i Atlas, the strangest part might not be what it does, but what it doesn't do. Because buried inside all the noise, the flickers, the alignments and the statistical quirks, there is something missing. Clarity. Think about how we send signals into space. The Voyager Golden Records, the Arecibo message, even modern radio bursts, all of them are designed to be clear, repetitive, and unmistakably artificial. But 3i Atlas offers us no such certainty. Instead, it wavers, vanishes, reappears, behaving like an ordinary comet right up until it suddenly doesn't. This silence between its signals is maddening. Was it intentional camouflage? Like a submarine pulsing its sonar in brief, cryptic bursts? Or is it simply nature playing tricks on us? The cosmos throwing dice that just happen to land in a way that mimics intelligence? Astronomer R.V. Loeb once said that extraordinary evidence requires extraordinary scrutiny. And here, scrutiny is exactly the problem. 3i Atlas moves fast. Too fast. By the time telescopes recalibrate, by the time instruments catch the anomaly, the window is gone. All we are left with is the echo, the absence, the silence. And silence can be more powerful than noise, because silence forces us to project, to wonder, to doubt. In this gap between what is observed and what is imagined, conspiracy thrives. TikTok threads it into alien beacons, Reddit twists it into Project Bluebeam rehearsals, and even sober academics, when pressed, admit we don't know enough to rule anything out. It's in this silence, in the spaces between data points, that the story of 3i Atlas becomes more than science. It becomes myth, suspicion, and perhaps a mirror reflecting our deepest fear, that if someone is trying to speak to us, we might never learn to understand them. But here's the problem. Every time scientists think they've solved the riddle of 3i Atlas, another detail slips through their fingers. The object's brightness fluctuates in ways that defy the neat predictions of comet physics. Its trajectory looks perfectly ordinary at first glance, but zoom in closer and there are subtle wobbles, small deviations that don't line up with the usual suspects like solar radiation or outgassing. It's as though a piece of the puzzle has been left out, and without it, the entire picture refuses to make sense. Some astronomers argue this is nothing more than incomplete data. Our telescopes can only capture so much and the rest might just be noise. But others aren't so sure. In science, unexplained anomalies have a strange way of leading to revolutions. Think about how the irregular orbit of Mercury eventually pushed Einstein toward general relativity. What if these faint discrepancies in 3i Atlas are pointing toward a breakthrough we haven't even imagined yet? And here's where the silence becomes deafening. In the archives of comet studies, there are no exact matches for this combination of behaviors. Not in Oumuamua, not in Borisov, not in the centuries of recorded comets stretching back to the earliest observations. 3i Atlas is carving out its own category, something between natural visitor and designed messenger. So the question we're left with isn't just what is it, but why is it behaving differently at all? Could this missing piece be evidence that we're observing not just a rock and ice fragment, but a deliberately engineered signal? Or is it a reminder of how much of the universe still hides behind the limits of our instruments? The more astronomers scrutinized 3i Atlas, the stranger it became. Data streams poured in from observatories across the globe, and instead of converging into a single, neat explanation, they began to clash. One telescope showed a gradual dimming, another caught sharp flickers of brightness that shouldn't exist in an ordinary comet tail. The orbital models ran on supercomputers, yet no matter how many inputs were adjusted, the simulations couldn't perfectly match the object's real motion. This isn't how science usually behaves. Normally, more observations lead to a clearer picture. But with 3i Atlas, every new data set introduced another wrinkle, as though the universe itself was daring us to decode a riddle. And that's when the parallels began to emerge. Many scientists couldn't help but compare this to Oumuamua, our first known interstellar visitor, which also danced around our expectations. Was 3i Atlas simply Oumuamua's cousin, another oddly shaped comet? Or were we staring at a pattern too significant to ignore? To skeptics, this is just what happens when you study rare objects with limited tools. You end up over-interpreting noise. But others pushed back hard. If the data is this stubborn, maybe it's not the instruments that are wrong. Maybe it's our understanding of what objects can be. After all, every major leap in astronomy has come from chasing anomalies, from Galileo's moons of Jupiter to Hubble's expanding universe. Could 3i Atlas be the next leap waiting to happen? And if so, what is the cost of dismissing it too quickly? Are we brushing past a signal simply because it doesn't fit neatly into our categories of comet, asteroid, or interstellar rock? The deeper we go, the more 3i Atlas feels less like a random wanderer and more like something placed, something that resists every box we try to force it into. If data is the language of the universe, then 3i Atlas was speaking in riddles. Astronomers began stacking observations side by side, looking for consistency. And that's when a strange realization dawned. Some of its irregularities weren't random at all. They formed patterns. Brightness spikes appeared in intervals, almost rhythmic, like a heartbeat echoing across billions of miles. Its trajectory, when mapped over time, hinted at subtle adjustments, tiny corrections that shouldn't exist if gravity alone was in control. These weren't big enough to scream engine or thruster, but they were just large enough to raise eyebrows among the careful, skeptical minds of astrophysics. The whispers grew louder. Could this be deliberate? After all, nature creates chaos but rarely precision, and in astronomy, regularity is often the fingerprint of intelligence. Pulsars, for instance, were once nicknamed LGM, Little Green Men, because of their clock-like radio pulses. Could 3i Atlas be hiding a similar kind of signal, cloaked inside its path and light? Skeptics countered quickly. Sunlight pressure, outgassing, ice fragments breaking away. These could all create the illusion of rhythm. But for every paper dismissing the anomalies, another popped up arguing that the explanations stretched physics past its breaking point. What unsettled the scientific community wasn't the lack of answers, but the possibility that they were staring at something outside the natural catalogue altogether. Patterns in space demand explanation, and 3i Atlas had handed us one of the most unsettling puzzles of the 21st century. And so, the stage was set. This wasn't just an object anymore. It was becoming a test of how far science is willing to stretch before it admits, we don't know what we're looking at. Patterns alone don't prove intelligence, but humans are wired to find meaning in them, and as soon as whispers of deliberate signals entered the conversation, imagination filled the gaps. Scientists, journalists, and online theorists each offered their interpretations, and the contrast couldn't have been sharper. In observatories, caution reigned. Researchers ran simulations to test whether solar radiation could mimic rhythmic brightness, or whether fragments breaking off could create phantom corrections in its path. Some models fit, others broke down completely. No matter how many variables they added, 3i Atlas kept behaving just a little too strangely, refusing to be fully tamed by physics. Meanwhile, outside academic halls, the story exploded. On forums and social media, threads lit up with claims that 3i Atlas was broadcasting a message, a warning, or even a countdown. To the curious, the heartbeat wasn't just a coincidence, it was an intentional beacon. Here's where the tension deepened. History had primed us for this. From the first radio signals mistaken for aliens to the "wow" signal of 1977, humanity has been conditioned to see patterns as communication. And 3i Atlas tapped directly into that instinct. But beneath the excitement was a sobering question. If these patterns were deliberate, who or what were they for? Were we the intended audience, or just bystanders catching a fragment of a conversation not meant for us? The possibility was electrifying, but it also forced astronomers into a corner. How do you study something when every explanation you offer only sharpens the mystery instead of resolving it? This was no longer about observation. It was about interpretation, and for the first time, even the skeptics admitted, the line between science and story was getting dangerously thin. By the time 3i Atlas had been tracked for several months, the object was no longer just an astronomical curiosity. It had become a cultural flashpoint. Every unusual reading, every unexplained fluctuation was dissected not just in research journals, but on late-night talk shows, podcasts, and TikTok feeds. The public wanted answers, and suddenly, science found itself performing under the harshest spotlight. Astronomers were caught in a delicate balancing act. On one side was the rigor of peer review, the slow grind of building careful models, running error checks and eliminating mundane explanations. On the other was a global audience asking urgent questions. Is this natural? Is it alien? Should we be worried? The frustration for researchers was that the more they spoke, the stranger things sounded. A comet shouldn't shimmer with rhythmic pulses. A random chunk of ice shouldn't seem to correct its own path. Yet, dismissing these anomalies outright felt dishonest. The result? Careful phrases like low probability natural explanations or insufficient data for extraordinary claims. But to the public ear, those words only fueled the fire. Headlines twisted caution into mystery. A hedge like unlikely became impossible. A phrase like anomalous became alien. And the object itself, 3i Atlas, transformed from a speck in the sky into a mirror, reflecting humanity's hopes, fears, and wildest theories. Behind closed doors, some scientists admitted what they wouldn't say on record. The data wasn't behaving the way it should. For them, 3i Atlas wasn't proof of anything alien, but it was a reminder that our models of the solar system, even after centuries of refinement, are still incomplete. This tension between what the public demanded and what science could honestly provide set the stage for the next phase. A phase where astronomy wasn't just about telescopes and equations, but about credibility, communication, and control of the narrative. And that's where the story truly sharpened, when silence itself became a statement. The press room lights dim, but the questions don't stop echoing. Behind the noise of reporters and the flicker of camera flashes, a quieter conversation is unfolding in the places where science thrives best. Not on stage, but in whispered debates, late-night calls, and encrypted emails exchanged between researchers who can't ignore what they're seeing. The strange thing about 3i Atlas is that, for all its chaos, its data holds hints of a rhythm. Small, recurring anomalies, fluctuations in brightness, periodic deviations in trajectory, signals that almost feel deliberate. To some, these are noise, the kind of statistical mirage that appears when too many eyes dig into too little data. But to others, they are breadcrumbs, leading towards something intentional. Picture this: an object racing through the solar system at speeds no spacecraft of ours could ever dream of achieving. And within its flickering light curve lies a sequence that looks suspiciously like repetition. Is it coincidence? A trick of perception? Or the faint outline of a message? The scientists most cautious remind us that patterns emerge everywhere, in the clouds, in stock market charts, even in the static of old radios. Our brains are wired to find order, even where none exists. But what unsettles many is how the so-called coincidences in 3i Atlas are stacking up. Too many rhythms, too many alignments, too many near misses of natural explanation. And as these whispers travel from private research notes to small conference rooms, one realization grows harder to ignore. If the pattern is real, then 3i Atlas isn't just an interstellar visitor. It's a signal, not of what it is, but of what it might represent. Because sometimes the scariest discovery isn't proof of aliens. It's the dawning suspicion that something or someone wanted to be noticed. Whispers can only stay whispers for so long. Eventually they spill into the open, and with 3IATLAS, they did, not in a dramatic press release, but in the cracks between conferences and the quiet courage of a few researchers willing to risk their credibility. One astrophysicist from Europe went on record: "If you plot the anomalies over time, it doesn't look random, it looks like structure." Her words, careful and understated, sent ripples across the community. Suddenly, what had been brushed off as coincidence was gaining traction as a legitimate research question. Of course, this ignited a clash. On one side, skeptics, armed with Occam's razor, insisting that the simplest explanation, dust jets, tumbling rotation, statistical noise must be correct. On the other, a smaller but growing group daring to suggest that if 3 IATLAS were engineered even partially, it would explain more than it complicates. This wasn't just a battle of data, it was a battle of worldviews. To acknowledge the possibility of intention meant rewriting everything we thought we knew about our cosmic solitude. To deny it meant risking the chance of missing history's most important discovery. And here lies the tension that keeps even the most seasoned astronomers awake at night. What if rejecting the extraordinary explanation blinds us to the extraordinary truth? In the silence between those debates, one thing became clear. 3 Atlas wasn't just a comet. It had become a mirror, reflecting humanity's deepest divide between those who fear being wrong and those who fear being blind. Scientific debates rarely spill beyond the walls of academia, but with 3 Atlas, the conversation began to leak into places far from observatories. Quietly, governments started to take notice. At first, it was subtle. A sudden uptick in classified meetings at space agencies, closed-door briefings with astronomers who normally lived in obscurity, intelligence officers quietly requesting raw datasets, not the polished, peer-reviewed papers, but the messy, unfiltered numbers. They weren't just interested in science, they were interested in intent. For them, the question wasn't only what 3 IATLAS is, but why it's here. Because if even a fraction of the engineered object hypothesis were true, the implications were enormous. Was it drifting aimlessly? Was it programmed to observe? Or worse, was it meant to send a signal? And with those questions came fear. Not the kind you broadcast, but the kind you whisper about in secure rooms. What if this is the last alien message and we almost ignored it? Meanwhile, the media started circling. Journalists caught hints of unusual activity. Freedom of information requests were filed. Rumours bled into the public sphere. Anonymous sources claimed space agencies were deliberately downplaying the anomalies. The more officials tried to stay quiet, the louder the speculation grew. 3 Atlas had left the realm of astronomy and entered geopolitics. Suddenly, this object wasn't just a puzzle for stargazers. It was a matter of national interest, even existential concern. And here's where the story takes a darker turn. When science stops being only about discovery and starts becoming about control. Once governments took notice of 3 IATLAS, the story was no longer purely about science, it became about power. Different nations looked at the same data and drew very different conclusions. In the United States, the official line was cautious. NASA publicly referred to 3 IATLAS as a rare interstellar comet, while behind closed doors, defense analysts pressed for contingency plans. In Russia, state media hinted darkly that Western astronomers were hiding something, while their own scientists quietly re-examined telescope logs stretching back decades. China, meanwhile, poured resources into independent sky surveys, hoping to gather their own unfiltered data, a chance to get ahead in the most important discovery in human history. Each country's interpretation was shaped not just by science, but by politics. Was 3 Atlas a threat, a beacon, or a rare opportunity to be the first to understand and possibly control evidence of alien intelligence? The rivalry didn't stay contained. Satellite tracking stations were upgraded. High-powered radio telescopes were pointed at 3 IATLAS for longer than scheduled. Even small nations with modest observatories suddenly found themselves contacted by larger powers, asked to share data or stay quiet. And here's the unsettling truth. The more governments tried to keep secrets, the more cracks began to show. Leaks surfaced. Emails and draft reports slipped into public view. Some revealed genuine scientific disagreement. Others hinted at classified observations never published in journals. The world's most advanced nations were playing a high-stakes game of trust and suspicion, and all of it revolved around one silent traveler drifting through the solar system, as if daring humanity to decide what story to tell about it. Because here's the paradox. When nations hoard knowledge, they risk losing the one thing science depends on most: collaboration. And without collaboration, the truth of 3 IATLAS becomes even harder to uncover. Secrecy and rivalry shaped the conversation on Earth. But what if that's exactly the point? Think about it. If 3I Atlas were natural, it wouldn't care how we responded. But if it were something more, something designed, then maybe its very presence is a test, not of technology, but of behavior. History tells us we don't always pass these tests. When new worlds were discovered centuries ago, nations rushed to claim land and resources, often with devastating results. The same pattern echoes today. The moment a mystery appears in the sky, suspicion, pride, and competition surface. So what if 3 IATLAS is a kind of cosmic mirror? A way of asking humanity, can you set aside borders, suspicions, and rivalries, even for one moment, to face something bigger than yourselves? It's a chilling possibility, because if this object is artificial, whoever or whatever sent it would already know how to read us. Our radio chatter, our rushed attempts to control the narrative, the fact that even in the face of the unknown, humanity still argues about who should own the truth. And here's the haunting thought. Maybe we're not being judged on how advanced our telescopes are, but on how advanced our cooperation is. Not whether we can measure 3I Atlas precisely, but whether we can share what we know openly without turning knowledge into a weapon. If that's the real test, then 3IATLAS isn't just an astronomical curiosity. It's a question, one that demands an answer. And right now, the way humanity is responding might be telling the universe more about us than we realize. Imagine this. A routine scan of cosmic noise suddenly shows a blip. At first, astronomers think it's interference, maybe a satellite glitch. But when the signal repeats, perfectly timed, something shifts. It's not just background static anymore. It's structured, deliberate. For decades, scientists have searched for a wow signal repeat. They expected it to come from deep space, but what if it came from something already inside our solar system? Something passing through. The possibility that 3IATLAS might not only reflect sunlight strangely, but also transmit a pattern, that's enough to raise goosebumps on even the most skeptical observer. Now, here's where the story sharpens. The structure of the signal, if it existed, could be compared to human-made binary code. Imagine astronomers debating late into the night. One swears it's natural, a pulsar echoing through dust. Another insists, no, this looks like engineering. And that's where humanity splits once again. Some scientists lean into the thrill. If it's real, this could be proof of technology not born on Earth. Others retreat, warning against hype, demanding evidence. Because in science, extraordinary claims require extraordinary proof. Yet, while they argue, one truth lingers in the background. The mere hint of such a signal already changes the way we see 3IATLAS. This is no longer just a rock. It's a mirror, reflecting back our deepest questions about who we are and whether we're truly alone. But here's the problem. Space is tricky. Signals can play tricks on us. Dust clouds, plasma fields, even the Earth's own atmosphere can twist radio waves into illusions. What seems artificial might just be nature's static dressed up as order. Still, the timing is suspicious. 3I Atlas streaks into our solar system, and suddenly data centers around the world log unusual bursts, not strong enough to call contact, but not weak enough to dismiss outright. Imagine the arguments in labs, teams replaying the data frame by frame, software engineers checking for compression errors, astronomers cross-referencing every known natural source. And then the question drops like a hammer. What if the signal isn't from deep space at all, but from this very object cutting across our skies? This isn't the first time such debates have erupted. The 1977 WOW signal still echoes in SETI circles decades later. Some believe it was a hydrogen beacon from another civilization. Others think it was just an Earth-based interference. But if 3I Atlas produced something even remotely similar, the implications are staggering, because this time the source isn't fixed in the stars, it's moving, passing by, almost like a message in transit. And that subtle difference reframes the entire discussion. Because if this signal was real, then we may have already missed our chance. A once-in-a-lifetime visitor may have swept past us, carrying secrets we only half heard. And this is where the real sting lies. Once an interstellar visitor leaves, it's gone. Unlike Mars or the Moon, we can't just send another probe later because there may not be another chance. 3I Atlas isn't part of our solar system's clockwork. It's a drifter, a messenger on a trajectory that will never loop back. Astronomers call this the missed opportunity problem. By the time we gather our instruments, secure funding, and organize international collaboration, the object is already shrinking into the black. Imagine standing at a train station, watching a single carriage blur past at nearly 140,000 miles per hour, and knowing that was your only ticket. That's the urgency 3I-ATLAS brought with it. Some scientists proposed rapid response missions, launching small probes with ion engines, or even piggybacking interceptors on rockets already in production. But missions like that take years of preparation. By the time blueprints are approved, the object is a fading memory, and so humanity is left with fragments, grainy telescope captures, spectral data that raises more questions than answers, and a few whispers of something extraordinary hidden in the noise. But here's the thought that refuses to die. What if 3I Atlas wasn't just another rock tumbling from nowhere? What if it was a deliberate pass-by, an engineered encounter designed to test us? Did we respond fast enough? Did we notice at all? Or did we fumble the one chance at a handshake across the stars? If 3I Atlas was simply a comet, then our instruments did their job. We tracked its orbit, measured its brightness, and catalogued it in the astronomical record. Case closed. But if it wasn't, if it was something more, then our response tells a very different story. Think about it. We had telescopes pointed at it, yes, but no spacecraft in pursuit, no global rush to intercept, no rapid mobilization the way we might if a threatening asteroid was inbound. Instead, we treated it like just another curiosity in the night sky. Was that exactly the test? To see how humanity would react to an unannounced visitor from the void? Some theorists suggest that if an advanced civilization wanted to measure our technological maturity, this is exactly how they'd do it. Send a fast-moving object that looks natural at first glance, but has just enough anomalies to provoke debate. If we could launch a mission in time, it would signal readiness. If not, it would reveal how much farther we have to go. And here's the unsettling part. We failed that test. The window closed before we could even organize. For some, that's a sobering reminder that while our instruments are good, our response systems are not. For others, it sparks a deeper fear. What if we were noticed and judged accordingly? But maybe the real story isn't about what we failed to do. Maybe it's about what comes next. Because if 3I Atlas was a trial run, it may not be the last. The next one could arrive in decades or tomorrow. And the question then won't just be what was it, but are we ready this time? If 3I Atlas was a test, then it wasn't the first. Think back just a few years earlier to Oumuamua, the first recognized interstellar object. Its odd trajectory, its unexplained acceleration, and its strange cigar-like shape raised questions scientists still argue over today. Some astronomers dismissed it as an icy shard from another star system, while others, including respected researchers, floated the possibility that it was something engineered. Now add 3I Atlas to that timeline, two unusual interstellar objects within a short span of human observation. Before Oumuamua, we had never confirmed any. Then suddenly, two in rapid succession, each carrying mysteries. Coincidence? Or is this the pattern? A drip feed of encounters designed to stir us, to push us toward awareness without overwhelming us all at once. The eerie part is that, in both cases, humanity reacted almost identically. First, excitement, then fierce debate. Finally, a shrug as the object slipped away beyond our reach. It's like we've been watching ships on a distant horizon, recognizing their sails for a fleeting moment before they vanish over the curve of the sea. And here's the unnerving possibility. What if Oumuamua and 3I Atlas aren't isolated wanderers at all, but connected events, a sequence, a conversation, or even a strategy, each one leaving behind unanswered questions, breadcrumbs scattered across the void? Because when you line them up in sequence, the pattern begins to look less like random chance and more like deliberate pacing. A story unfolding slowly, chapter by chapter, with us as the reluctant readers trying to make sense of it all. And the question becomes, are we only now opening the book? Or have we been skipping pages of a story that's been told all along, hidden in plain sight? If Oumuamua and 3I Atlas are chapters in the same cosmic book, then what about the silence between them? Because sometimes what doesn't happen tells us just as much as what does. For centuries, humanity looked up at the sky and saw only the predictable motions of planets, stars, and comets. Nothing unusual, nothing unexplainable. Then, in less than a single decade, two mysterious interstellar objects slipped through our solar system. Astronomers call this the small number problem. With only two examples, it's impossible to know if this is a new era of discovery or just a statistical blip, but others suggest a different interpretation. What if the silence before was intentional? What if Earth was never meant to notice until now? Consider this. Both objects appeared during the age of global telescopes, instant communication, and viral media. For the first time in history, one strange discovery could ignite debate not just in academic journals, but in millions of minds across the world, all within hours. The timing is almost too perfect. Not the 1800s, not the Cold War, but now, when the infrastructure to spread an idea faster than light across human society finally exists. That makes the gaps between these cosmic visitors feel less like empty space and more like carefully placed pauses, like waiting for the audience to lean forward, to grow restless before delivering the next act. So, is this randomness dressed up as narrative? Or are we, perhaps unwillingly, already inside someone else's story, one that has been waiting for the right century, the right technology, the right audience? And if that's the case, then the silence isn't empty at all. It's loaded, intentional, the kind of silence that comes before a voice speaks again. Here's where things get stranger. If we step back and crunch the numbers, the odds of seeing not one but two interstellar objects in such quick succession is staggeringly low. Before Oumuamua, the consensus was that we might expect one visitor like this every few 100,000 years. A cosmic lottery ticket so rare, entire civilizations could rise and fall without ever knowing one had passed. And yet, less than 3 years later, ATLAS appeared. Mathematically, that's not just unlikely, it's suspicious. It's like flipping a coin 1,000,000 times and landing on heads twice in a row after centuries of nothing but tails. When probabilities start breaking down like this, scientists look for two possible explanations. Either our models are wrong, or the universe is throwing us a curveball. If the models are wrong, it means the galaxy is far more chaotic and dynamic than we ever realized. Streams of wandering debris, fragments of shattered worlds, slipping through interstellar space far more frequently than we thought. That in itself would be revolutionary, rewriting our understanding of how solar systems evolve and die. But if the models are right, then the appearance of these objects back to back begins to look like something more deliberate, as if they were placed here to be noticed. The trajectory, the timing, even the way they were discovered, almost staged, like someone wanted to make sure we'd see them. And this is where the human imagination collides with cold statistics. Because when the numbers whisper impossible, people begin asking different questions. What if the impossibility is the message? What if the very fact that Atlas exists at all, so soon after Oumuamua, is its own form of communication, one that doesn't need words, only improbability? The more you look at the math, the less random it feels, and maybe that's the point. Now here's the paradox that unsettles astronomers. ATLAS carries no radio signal, no obvious transmission, no beacon. It drifts in silence. Yet that very silence has become its loudest feature, because in science, absence is not nothing, it's data. Think of how SETI works. For decades, radio telescopes have swept the skies, listening for pings, pulses, or bursts of unnatural rhythm. But what if intelligence doesn't broadcast? What if the real message is in the placement, the timing, or even in the pattern of silence itself? This is where Atlas becomes more than a rock tumbling through space. Its trajectory wasn't just unusual, it intersected our neighborhood in a way that was hard to ignore, almost optimized for discovery. And if Oumuamua was the first knock on the door, Atlas might be the pause after, the waiting silence daring us to recognize the pattern. Astronomers have quietly debated this in journals and late-night conferences. Could interstellar objects themselves function as markers? Passive carriers of meaning, not through what they emit, but through the improbability of their arrival. After all, civilizations may choose to hide their energy signatures to avoid detection, but they can't hide the footprints of their artifacts. The silence becomes unsettling when combined with the statistics we just explored. Two objects appearing impossibly close together in time, neither broadcasting, both slipping past just close enough for us to notice and just far enough that we cannot touch. It's the kind of silence that isn't empty, but charged, like standing in a vast cathedral after the last note has faded, realizing the echo itself is the message. And that raises the question that no equation can solve. Are we truly looking at cosmic accidents? Or is someone, somewhere, leaving breadcrumbs, one quiet anomaly at a time? But silence alone isn't what shakes the scientific community. It's the patterns hidden inside the silence. When researchers at Harvard and other observatories modeled ATLAS's orbital path, they noticed something strange. Its speed and trajectory lined up in ways that seemed almost deliberate. Not like the chaotic randomness we expect from interstellar debris, but more like a route chosen with precision. Picture this. If you release billions of icy bodies from a distant star system, only a vanishingly small fraction would ever graze a solar system like ours. Yet within just a few years, we saw not one, but two objects pass by. Statistically, that's like winning the cosmic lottery twice in a row. And history teaches us that when improbable events stack up, we should look closer, because sometimes improbability is just the mask of intention. Some astrophysicists have quietly floated the idea. What if these interstellar visitors are more than wanderers? What if they're breadcrumbs, markers, or even messages dropped across time and space, Not communication in words, but communication in probability, written into the language of statistics itself. It's almost like seeing crop circles, not in wheat fields, but in orbital mechanics, a signature you can't erase because it's written in gravity itself. Skeptics call it coincidence, a trick of small number statistics. But others point out how often coincidence has collapsed under deeper scrutiny. Think of pulsars, first thought to be odd noise, then later recognized as spinning neutron stars. The cosmos has a habit of turning weird coincidences into breakthroughs. So the real question isn't whether Atlas is shouting at us with radio waves, it's whether it's whispering through math, betting that one curious species would eventually connect the dots. But here's the part that lingers long after the telescopes go dark. What if none of this is coincidence? What if Atlas is not noise in the data, not a wandering piece of ice, but a deliberate question placed in our sky? Because in the end, that's what this object really does. It forces us to confront ourselves, not just as observers, but as participants in a much bigger story. If someone, or something, has been dropping markers into the galaxy, then noticing them may be the true test of intelligence. Not building rockets, not splitting atoms, but recognizing when the universe itself is nudging us. And if it is a message, then it's not written in English or mathematics, but in wonder. A riddle carved in silence and trajectory, waiting for someone, somewhere to say, "We noticed." Of course, maybe Atlas will eventually reveal itself as just another strange but natural visitor. A frozen time capsule carrying nothing but dust and gas, but if that's the case, even then, it's already succeeded, because it's made us look up, question and wonder in ways we haven't in decades. It's reminded us that the sky isn't just background, it's alive with mysteries. So as you close your eyes tonight, ask yourself, was ATLAS just a comet, or was it something more? A mirror held up to humanity, asking not if we are alone, but if we are ready to notice when the universe finally answers, because sometimes the silence itself is the message. And maybe, just maybe, that's what 3IATLAS has been trying to tell us all along.